In this video, I will be discussing the different ways you can represent reactions in aqueous solutions. There are basically three different ways you can represent a reaction when it's in aqueous solution. The first way is the one we have always used. These are the molecular equations. And well, the molecular equations shows the full formula. It shows the reactants and the products as they appear in nature. So you could say it's an intact form. So intact. And well, it usually undergoes like this. So you have a compound AB. In this case, it is aqueous plus CD, aqueous 2, and by double replacement, you will form AD aqueous plus CB aqueous. Now this aqueous here, you can determine by the solubility rules I discussed in the previous video. However, this is not going to be as it occurs every time. You may get, let's say, you may have two reactants that are aqueous, but you may get something like AD solid plus then CB maybe aqueous, but that's not how it is horrible. That's not how it may occur every time. You have to determine this by using the solubility rules. One thing I forgot to mention before was that if you want to you can write the state of matter under the compound. So like what I wrote before, solid. So this thing right here. And well, solid, as you may know, is written by an S. Liquid is written by an L. Gas is written by a G. It's usually a small g. And if something is aqueous, so it means that it can dissolve in water. It writes as that. So keep this form in mind whenever you see a compound. Actually, let me fix this. It looks horrible. So it's a small g for gas. Now let's go to the second representation of a reaction, and that is what we call a total ionic equation. This is the second. So, damn it. Okay. And what the total ionic equation represents is all the aqueous species that you have, all the aqueous compounds will be in its ion form. So if you have something like AB aqueous, it will ionize into A plus, it'll be aqueous 2 plus B minus, and it will be aqueous 2. However, if you have something like a solid, so let's call it CD, it will stay the same. So it won't break down into its ions because it is not a strong electrolyte. So let's do an example by using the same formula I used for as the molecular one. So we had that, right, AB was aqueous plus CD was aqueous 2, and then this would form AD, which was a solid, and CB, CB, which was aqueous. So the way you would write its total ionic equation is, as I said before, if it's aqueous, you will separate it into its ions. So you'll have something like A plus aqueous plus B minus aqueous. Then you do the same for the C and the D. So you have to do it in both sides of the equation, the reactants and the products. Now we have this solid here, so that doesn't ionize at all. And then we have C plus aqueous plus D minus aqueous. So that would be the total ionic equation using this molecular equation. So this would be, I'm going to write it in blue, molecular equation. This would be total ionic equation. However, there is one more type of representation. And that is what we call a net-ionic equation. And well, what a net-ionic equation is the simplest representation of your whole equation. It is, in other words, the simple representation of your total ionic equation. So you simplify the total ionic equation you have. So let's use that one to show you how it goes. So I think we had A plus aqueous plus B minus aqueous plus C plus aqueous plus D minus aqueous. And then what this was formed was, I think AD was a solid. Finally, it would break down into C plus aqueous and D minus aqueous. Yeah, that says aqueous. So the only things that will show in your net ionic equation are pretty much the solids, and the products it will be like the solids, and in the reactant side it will be the ions that form the solid. So you would omit the spectator ions, and that is something we don't know. So a spectator ion would be the ions that simplify each other. So like you see, there's a C plus in here, the reactant side, and there's a C plus in here. So those two, these are spectator ions. So the things that will cancel out in your net ionic equations are called the spectator ions. Now let's get back to getting the net ionic equation. And how you get it is, well, as you may see, the C's will go with the C's. Then we have this D here and this D here, right? I'm sorry, this here wasn't a D, it was a B. So let me fix this very quickly. This was aqueous, okay. So this B would cancel out with this B, and what you see remains is in the product side the solid, and in the reactant side the ions that form the solid. So your net ionic equation would be A plus aqueous plus D minus aqueous, forming AD as a solid. So it is, let me write, net ionic equation. So it is the simplest way you can represent your equation. And what you do is you cancel out your spectator ions. So these are, again, the spectator ions. And that is how you find the molecular equation, the total ionic equation, and the net ionic equation of your reaction.